Welcome to Chapter 7. So we are following the order of topics in chemistry, the central science, by Brown, LeMay, Burston, and Murphy. And we make it to Chapter 7, which is about the periodic properties of the elements. And so it's no surprise that I have the periodic table behind me, perhaps. The chapter launches off with a very brief section on the development of the periodic table. It's nothing like a comprehensive history. It's just giving us a basic sense of the development of the periodic table. Of course, if you go to chapter 2, you have actually much more on the development of atomic theory, protons, electrons, and things like that. And of course, that's part of this, interweaves with this story as well. Well, let's start off with elements that have been known since time immemorial. So like gold and silver, obviously these were precious metals in the ancient world as well. They've been known for a long, long time. And in fact, I used to think, well, why is it that the symbol for gold is AU? And why is it that the symbol for silver is AG or the symbol for mercury is HG? I mean, AU, neither of these letters are in the word gold, and AG, neither of those letters are in the word silver. And where did HG come from? Well, these are from the Latin names for these because these are really old metals, right? They've been, obviously they're all of the naturally occurring substances are old in that sense, but these have been known for a very, very long time. And so the Latin word for gold is arium, so that's where the AU comes from. So some elements have been known for a long, 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 long time. Now, you might be surprised to know that in the year 1800, there were only 31 of the elements were known, that is, in their elemental form. Obviously, they were around in compound form, but you can't, if you don't know chemistry, you can't see beyond the compound to the elements that make up the compound. And so there were only 31 of the elements that were known in the year 1800. Now let's move forward to 1850. By the year 1850, there were 63 of these known elements. So we added 32 to our knowledge bank. And what brought this about were advances in chemistry that allowed the isolation of elements become more feasible. So perhaps it's no surprise that about 1869, Dimitri Mendelev, a Russian scientist, noticed similar chemical and physical properties when elements were arranged by their atomic weight. By the way, there's a guy named Lothar Meyer in Germany about the same time who came up with the same thing. But Mendelev is usually the father of the periodic table. Usually Mendelev is the one who's pointed to, although they both published their works in about the same time. And what Mendelev discovered is that if you arrange the known elements in a certain way, they have periodic properties. What I mean is that they, you go through these elements and they have a spectrum of properties, and then you start all over again, and you have elements that have again a spectrum of similar properties. It's like you can line them up and down into columns, and you would find that this group of elements by atomic weight have similar properties. And as you go up in atomic weight, each group has similar properties. And of course, the periodic table is born. And in fact, this allowed Mendeleev to predict elements that weren't discovered at that time. So Mendeleev predicted the discovery of gallium and germanium. He called them ec-aluminum and ec-silicon because he thought they should be under aluminum and under silicon in his chart. And sure enough, they were eventually discovered. And thus the periodic table is born. Well, you might remember from chapter 2 that in 1911, Ernst Rutherford proposed a nuclear model of the atom. Before him, like J.J. Thomson, he had proposed a plum pudding model of the atom, where you have a blob with electrons. He discovered electrons with electrons in the blob, like raisins in a pudding. Man, that I'm ready for lunch, aren't you? But anyway, it was actually plums, not raisins, but I prefer raisins to plums. That's not important right now. So Rutherford had shot rays, through substances and found that most of the time it didn't bounce back, but sometimes it did. And that led him to believe that atoms might have a kind of a cluster of stuff in the middle, the nucleus, with more empty space around it where the electrons were. And so the nuclear model of the atom came from Rutherford. 2 years later, in 1913, Henry Moseley had been bombarding various elements with X-rays, and he found that he could also, like Mendeleev, line them up according to the way the properties, when they're bombarded with X-rays, developed. And so he suggested giving numbers to them rather than arranging them by atomic weight. And this idea of arranging these elements by atomic number, which later turned out to be, I think it was in 1919 maybe, that Rutherford officially discovered the proton. But Moseley proposed that this hypothesis would explain the numbers, the atomic numbers. And of course, it became true. Notice the predictive property of science when you form a hypothesis and you test it. Einstein did the same thing. Anyway, that's not important right now. So Moseley proposed that we arrange the elements by atomic numbers rather than atomic weights. And this solved some of the problems that had been left in Mendelev's proposal. So for example, argon actually has a larger atomic weight than potassium. And yet, in terms of the recurring properties, it would have made more sense for argon to come before potassium in the periodic table. Well, if you use atomic numbers, everything works out. Argon, based on the properties of bombarding it with X-rays, argon comes before potassium. And of course, we now would say, after Chadwick in the 1930s, I think he discovered neutrons, that the reason why argon has a higher atomic weight than potassium is because it has more neutrons than potassium. And anyway, but this idea of using atomic numbers rather than atomic weights makes everything line up. And of course, this led Moseley to propose more holes in the periodic table to predict more elements that were later discovered. Of course, in more recent times, elements have been produced in particle accelerators where we've gone beyond the natural occurring elements. I can't remember exactly how many. I'm going to look it up before I finish this video. I think it's around 90 elements, maybe a little more than 90 elements. Maybe I'm going to guess 93 that appear in nature, and the winner is 92. Okay, 92. So the periodic table has grown a little because of work that's been done in particle accelerators. Of course, anything past 100 and up in there is going to be pretty unstable. Well, this has been a brief development of the periodic table as a part of our quest through chemistry, the central science.